Welcome to Chapter 7 on energy and energy transfer. And our problem is a 100-gram bullet is fired from a rifle having a barrel 0.600 meters long. Assuming the origin is placed where the bullet begins to move, the force in newtons exerted by the expanding gas on the bullet is 15,000 plus 10,000 x plus 25,000 x squared, where x is in meters. And we're given the mass, which is 100 grams, and then we're given delta x is 0.600 meters. And this is our force function. What we want to find is A, the work done on the gas, travels the length of the barrel. Part B is a what if. So what if the barrel is 1 meter? How much work is done, and how does this value compare to our value calculated in A? So we'll start with A. Now here's the function for work. Work is the integral from the initial position of x to the final position of x of the function of x dx. So now we plug in our givens. So x initial is 0, x final is 0.600 meters, and this is our function. This really simple integration. We simply use the general formula, and we get 15,000 x plus 5,000 x squared minus 25,000 over 3x cubed, evaluated from 0.600 to 0. And when we look at it like that, what we realize is that if we put it onto our calculator, 15,000 times 0.6 equals that, plus 5,000 times 0.6 squared minus 25,000 divided by 3 times 0.6 raised to 3, we get 9,000. So you get essentially 9,000 joules, which is shown right here. 9,000 joules is our answer for part A. Now for part B, we simply continue the same thing, except and we get the same value, but notice how our initial changes to 1.0. So that's all the difference is the function is actually the same, and you can do the algebra again if you want, but actually the final function you get here is the same. All you worry about is this. When we plug that in, we get 15,000 minus 5,000 minus 25,000 over 3, which gives us 11,666.6, blah blah blah. And you can just estimate it where you want depending on the sig figs. In this problem I would go with 3 because we're given 0.600 meters, so we'd go with 11,700 joules. So that would be the correct sig fig estimation, but it depends on what your book's looking for. And how does this compare? So we notice that this is more. Clearly this is more. And because that's safe to assume because it's traveling over a larger distance. But another thing we notice is not linear, and that's because the function is not linear. So those are the two main things we noticed. And that's pretty much it. That's part B's answer, part A, and boom, there you go.